back to my YouTube channel. My name is Sarita from Sri Venkateshwara College of Engineering, Computer Science Department. In this video, I am going to discuss about corrosion and its types and corrosion control methods. Now, let's get into the topic corrosion. Corrosion is a natural process that occurs when metals react with their surrounding environment such as air, water or chemicals. It leads to the deterioration and gradual destruction of the metal material. Corrosion can weaken structures, damage equipment, and impact the functionality and appearance of objects. It is a common issue for metals like iron, steel, aluminum, and copper. Preventive measures such as protective coatings or a regular maintenance are often necessary to mitigate the effects of corrosion. And here some examples for corrosion are rusting of iron, green scales formed on copper vessels, tarnishing of silver. There are mainly two types of corrosion: differential metal corrosion, differential aeration corrosion. The differential metal corrosion occurs when two dissimilar metals are in contact with each other in the presence of an electrolyte such as water or a corrosive solution. The two dissimilar metals here taken as anode as zinc and cathode as copper. The difference in their electrochemical potentials leads to the formation of an electrochemical cell resulting in galvanic corrosion. So, differential metal corrosion it is also called as galvanic corrosion. The galvanic corrosion rate can be calculated using the galvanic corrosion equation, which is as follows: corrosion rate is equal to K of E1 minus E2 divided by Rw, where Cr represents corrosion rate, K stands for constant related to the specific metal system, E1 stands for electrochemical potential for the more noble metal, and E2 electrochemical potential of the less noble metal, and Rw stands for resistance of an electrolyte between the two metals. So it's important to note that this equation provides a simplified approximation and that other factors such as temperature, surface area, and local conditions can also influence the corrosion rate. And here some examples for differential metal corrosion are galvanized steel and aluminum, copper and iron, stainless steel and carbon steel, titanium and nickel. And these examples illustrate how the difference in electrochemical potentials between the dissimilar metals can lead to a differential metal corrosion. And here for galvanized steel and aluminum, there is a lot of difference between electrochemical potential values. The galvanized steel varies from minus 0.7 to minus 1.1 volts of electrode potential, and for aluminum is minus 1.66 volts. When it's compared to copper and iron, copper it is for 0.34 volts and iron has minus 0.44 volts. Stainless steel and carbon steel. Stainless steel as varies depending on the substrate composition. It can range from minus 0.3 volts to plus 0.8 volts. The carbon steel as minus 0.6 to minus 0.8 volts. When it's compared to a titanium and nickel, titanium has minus 1.63 volts and nickel has minus 0.25 volts. Next, the differential aeration corrosion. Differential aeration corrosion, also known as an oxygen differential cell corrosion, is a type of corrosion that can occur in water lines as well as in pitting corrosion. Differential aeration corrosion occurs when there is a difference in oxygen concentration between different areas of a metal surface. This difference in oxygen concentration can be caused by factors such as variations in water flow, temperature, or the presence of dissolved oxygen. There are mainly two types of corrosion in differential aeration corrosion, that is waterline corrosion and pitting corrosion. In waterline corrosion, differential aeration corrosion can occur when there is a localized difference in oxygen concentration along the waterline. This can be due to a factor such as turbulence in the flow of water or the presence of oxygen-rich areas near fittings or walls. This differential aeration can lead to a corrosion on the metal surface where there is a lower oxygen concentration, causing degradation and potential leaks in the water line. Pitting corrosion. Pitting corrosion can occur within the anodic area of the differential erosion corrosion cell. The anodic area, which has a lower oxygen concentration, becomes deprived of oxygen and accumulates metal ions under certain conditions. Localized corrosion in the form of pits can initiate and propagate in this area. This presence of pits exacerbates the differential erosion corrosion process. Pits provide localized areas of increased corrosion activity as they concentrate the electrochemical reactions and create more aggressive environments within the metal surface. The combination of differential erosion corrosion and pitting corrosion can lead to accelerated metal degradation and potential structural integrity issues. And there are several methods to use it for corrosion control. There are mainly protective coatings, cathodic protection, galvanic corrosion, alloying, environmental modifications, design considerations, regular maintenance. When it comes to our protective coatings, applying the protective coatings such as paint or a corrosion resistant metal layer creates a barrier between metal surface and the corrosive environment. This prevents direct contact and slows down the corrosion process. In this figure, we can see they are applying paint on the some steel metals. Cathodic production. This method involves connecting a sacrificial anode or a more reactive metal to the metal being produced. The sacrificial anode corrodes instead of the metal, providing cathodic production. Galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in the contact in the presence of an electrolyte. To prevent this type of corrosion, insulating materials or coatings can be used to separate the metals. When it comes to alloying, adding certain elements to these base metal can improve its resistance to corrosion. For example, stainless steel contains chromium, which forms a protective oxide layer on the surface. Environmental modifications. Controlling the environment around the metal can help prevent corrosion. This can involve reducing moisture levels, controlling temperature and humidity, and minimizing exposure to corrosive chemicals. Design considerations. Proper design can minimize the effects of corrosion. This includes avoiding sharp corners and surfaces where the moisture can accumulate, providing adequate drainage, and using corrosion resistant materials in critical areas. At last, regular maintenance. Regular inspection, cleaning, and maintenance of metal structures can help identify and address corrosion issues before they worsen. By employing these corrosion control methods, it is possible to significantly reduce the impact of corrosion and prolong the lifespan of metal materials. So thank you. Please like, share and subscribe the video.